stress now, where Vy is equal to what? 60. No, 80.
80.
And then we multiply 498.714. Or I should have done the other way. It's 498.714. Then we multiply by 80. Okay. So 498.714 multiplied by 80 is 39.897. Times 10 to the power 6 Pascal. Okay. So now we realize that the normal stress and the shearing stress are quite high, are almost similar, right? They're so the next thing we are going to do, okay? So let's see what we have now, okay? So we know that if I draw and okay, I'm going to copy this whole thing, okay, and go to the next page because I need more space. I think this is the fun part of the course. Is you actually apply and you can actually select a piece of steel and get it to work, okay? After so long, right? It takes time to train, okay? Right, so now we are going to use Mohs circle, apply Mohs circle. Okay, we are going to apply Mohs circle to determine the principal stress. Okay. So if we look at our element, we draw our element. Because the structure is symmetry, compression and tension are the same. Magnitude are the same. Okay, so I'm going to assume it to be tension. So we know that if this is our x and y, we know that our normal stress is equal to what? 47.98. Then we have our shearing stress to be at 39.897. Okay. So if we are going to sketch Mohs circle, I told you guys, right? Everything goes in, you know, kitchen sink, you know, everything. Right? To do real design work, okay, you have to know all this. It can be a mechanical engineer or a civil engineer or structural engineer, all these are important. So this is our normal stress, this is our shear stress, and then this is just a sketch. Okay? We know that we have one value over here. Okay, so this is our stress X line, this is our stress Y, and then the shear is somewhere around here. Okay, element rotate clockwise, element rotate anti-clockwise. So for the 47.98 is going anti-clockwise. So this is your point X, and this is your point Y. Okay, then from here we know that we have to draw a line, and then from here go on. Hey, we draw Mohs circle. Okay, we sketch Mohs circle. This is just a sketch. Okay, so this is our mole circle. So what we are trying to find out here is we are trying to find our stress A and stress B value. More important is our stress A because that's where it's going to be maximum. Okay, so from here we can directly calculate our stress average, right? So we can determine our so we will draw our, this is center of the circle, so we can determine our stress average, and then after that we need to determine our tau max, right? And before we do anything, let's do the real engineering work, right? Let's do 3D mole circle. We know at that one stress state, Z will be over here because Z has 0 normal stress and 0 what? Shearing stress. So therefore, it is safe because if I were to draw 2 other circles, one circle is here, right? And the other circle is over here, right? We know the XY plane will carry the highest what? Maximum shear stress. Always check. Okay, I was an expert witness in one case where a structure failed and someone died. Sorry, 2 people died. Okay, and this is what went wrong. Okay, there was no checking about the applied principal stresses, whether is it in plane or out of plane. Okay, so you have to check. So from here, we now can determine, we have the confidence that the plane that we are analyzing has the highest shearing stress, okay, and also the biggest circle, basically. So from here, we can calculate our average stress is equal to 47.98 plus 0 divided by 2. Okay, so 47.98 divided by 2 is equal to 23. Wait, did I get 47.98? What is my stress? Oh, 47.68. Hey, hey, hey. Yeah, so 47.68 divided by 2 is equal to 23.84. And then tau max, which is the radius of circle, will be equal to square root 23.84 times 10 to the power 6 squared plus by 39.897 times 10 to the power 6 squared. Wait, I'm scribbling now. I should slow down. If I can't finish, I can't finish. I should slow down. 39.897 times 10 to the power 6 squared. So this whole term will be equal to 23.84 power 6 squared plus by 39.897 power 6 squared. Square root the whole thing is equal to 46.477. 46.477 times 10 to the power 6 Pascal. So therefore, the stress A will be equal to 23.84 times 10 to the power 6 plus by 46.477 times 10 to the power 6. Okay, so 23.84 power 6 by 46.477 power 6 is equal to 70.317 times 10 to the power 6. That is your maximum stress. Now, that is only for one point. Okay. Next, we are going to check when X is equal to 2.4, where Vy is equal to 0, Mz is equal to what? Mz is equal to 48 times 10 to the power 3 Newton meter. So this one is straightforward. Okay. So we know that now this is at a different location. This is x is equal to what? 2.4. Okay. So from here, we know that the normal stress, right? The normal stress x is equal to what is the coefficient? 2.98 times 10 to the power 3. Okay, so 2.98 times 10 to the power 3 multiplied by 48 times 10 to the power 3. Okay. Can you see why I calculate the coefficient? It's so easy now, yes or no? We just put the numbers now. So 2.98 power 3 times by 48 power 3 is equal to 143.04 times 10 to the power 6. And then the shear is equal to 498.714 multiplied by 0 is equal to 0. Okay. At the same time, you can calculate your stress average. It's equal to 143.04 times 10 plus by 0 divided by 2. So 143.04, 71.52 times 10 to the power 6 Pascal. I apologize. This is all times 10 to the power 6. So we have one value. So from here, our tau max is equal to also equal to 71 point what? Our tau max is equal to 71 point 5.2 143. .04. Oh, I'm being silly. So this the tau max is also equal to wait, it's not, is it equal to, because we have zero shear stress, right? So zero shear stress is a stress average square. It's also the same. So your stress A, right, is equal to 71.52 times 10 to the power 6 plus by 71.52 times 10 to the power 6 is equal to 143.04 times 10 to the power 6 Pascal. This is because we have what? We have zero shear. So when a zero shear, we are at the what? Principal plane. Okay, that's why the stress we calculate is also our principal stress. Okay.
Sorry,
And
Eugene.
then finally,
Eugene,
yes.
just a quick question. How we draw a Morse circle when the shear stress is zero?
Like now, for now, we have construct once and that's enough.
We just put it in the formula, yeah?
Yeah, that's what I'm doing now. Okay.
Oh, okay.
Ask Dula, ask. Would the exam just have one question this big? Ask Dula, you will have two questions this big. Okay, not one question this big, two. Two questions this big, not one. Okay. They are big questions. Okay. Asdullah, does that answer your question? It's a big question, I know. So the next one, where x is equal to 3.2, right? So we know that Vy is equal to what? Vy is equal, I forgot. Vy, wait, I can't remember what's our Vy. It's such a big question as Dola say. I can't, so it's minus 40 and 32. Okay, so minus 40 mz is 32. Okay, but you see, once the analysis is done, it's so easy now. Yes or no? You just put in numbers and get easy marks. I like this question.